video R3. We're going to talk about complex numbers. Had all kinds of trouble with my machine today, so we have most of the notes for this video already on the screen, and we'll just try to add a few things as we go along. I'm going to be talking about complex numbers here. A complex number is a number made up of a real part and an imaginary part. In this particular number, 3 plus 2i, the 3 is the real part and the 2i is the imaginary part. It is possible to have a complex number that only has part of that. Because the real part was 0, you might have just 2i, or because the coefficient of the I was 0, you might have just 3. This would be called a pure real or a pure imaginary number. Now, we deal a lot with complex numbers when we deal with things like quadratics. One of the most important terms we run into with complex numbers is the conjugate. The conjugate of a complex number has the sign of just the imaginary part changed. So the conjugate of 3 plus 2i would be 3 minus 2i. We have changed simply the sign of the imaginary part of the number. So the conjugate of 3 plus 2i is 3 minus 2i. The conjugate of 3 minus 2i is 3 plus 2i. Now the nice thing about complex numbers is if you multiply their conjugates together, you end up with a pure real number. 3 plus 2i times 3 minus 2i is 13. That's a pure real number. There is no imaginary part. Would like to point out you can do this multiplication on your calculator. This I can be found above the decimal point. So you can simply type in 3 plus 2i times 3 minus 2i, and it will give you 13 as your answer. Any type of calculation with an imaginary number can be done on your calculator. Now, one word of caution, 3 plus 2i divided by 3 minus 2i. What am I going to remind you to do here? Remember, put these numerators and denominators in parentheses. Numerator always goes in parentheses. The denominator always goes into parentheses. And it will give you the answer. Now, on your calculator, it's generally going to give you that answer in decimal form, and you're going to need to change it to a fraction. So go to Math, change to a fraction in order to get 5 over 13 plus 12 over 13i. You might want to try that on your calculator right now. Make sure that you can change that decimal answer to a fractional answer. Now, a few of you have an operating system where that doesn't work, where you don't get the 5 plus 13 plus 12 over 13i. In those instances, you have to take the first decimal, the real decimal, change it to a fraction, then the imaginary decimal, and change it to a fraction. Don't put the I in. There are a few operating systems for calculators out there that won't change an imaginary number to a fraction. Now, remember what I is. I is the square root of negative 1. So the square root of negative 36 is 6i. The square root of 36 is 6. And then the square root of a negative is I. You can build a factor tree for this and figure that out, or you can just type it in your calculator. It will tell you square root of negative 36 is 6i. Now, square root of negative 7, it won't tell you that that is I squared of 7 because it'll give you a decimal approximation of this 7. You need to know that this negative becomes an I, and then I've got a square root of 7. There is a program on your calculator that will change this for you to the proper form. Go to Program, Algebra 2, and Rad. This X that's in front of this, lost part of my radical here. Let me finish filling that back in. This X is the index to the radical. That's going to be 2 for square roots. And we don't normally write that with a square root, but it would be right here for this square root of negative 36. So if I wanted to do the square root of negative 36, when I ran this program, it asked me for X. I'm going to put 2 there as the index to my radical. And then I'm going to put negative 36 as the number under the radical. This is one of those rare instances where your calculator will actually go ahead and give you this radical form here for the 7. So if I put 2 and then negative 7 under the radical, it will tell me I square root of 7. If that index is not a 2, you're going to need to put in whatever it is. For example, if I had the cube root of 16, this works whether or not there's an I. If I have the cube root of 16, it's going to do the cube root of 16, you could build a factor tree, but you can also type it in your program, and it's going to tell you 2 root 2, because you had 3 2's and then a 2 left over. Now, this program is going to put an x right here. You're going to need to remember that that x is actually a 3. You need to keep the same index that you had when you started the problem. It will work whether or not those are imaginary numbers. Now, this will also work for long expressions like this. 6 minus 3i plus 4 minus 5i times 6 plus 2i minus 5 plus the square root of negative 36 plus the square root of 5. You could do all of that by hand. You could FOIL this. You could simplify this a whole lot faster on the EOC to just type it in your calculator. Now, your calculator is going to give you this decimal answer, so you're going to need to look for a multiple choice that has that same answer. So first you're going to look for a negative 19i, and then you're going to look for a number that simplifies the 37.236. That happens to be 35 plus the square root of 5. But if you looked for numbers that were obviously somewhere close to 37, that were obviously positive, you should be able to narrow your multiple choice answers down very quickly and then type in 35 plus the square root of 5 in order to know that it's the correct answer. Another example, you might try typing this in your calculator. Make sure you get the right answer. 42 plus the square root of negative 5 minus 17 minus the square root of negative 16. It's going to give you 25.6236i, and you're going to be looking for a real part that's 25 and an imaginary part that's approximately 6.236. So one of the multiple choice answers might be 4 minus the square root of 5. You'd know that would be less than 6. You might have a negative sign here in a multiple choice answer. You'd know that wasn't the correct answer. You might have something here that wasn't 25. You would know that would not be the correct answer. So you're looking for the one that matches up. Eliminate all your answers and then type in this expression, and at that point you should be able to match up for the correct one. Probably not the way I'd want you to do it if we were doing it in class, but it's a really great shortcut to use on the EOC. Just start eliminating those answers and get the one that works out for the correct answer.